expanding as more activity is happening. Messages can be thought of as transactions. There are constant transactions and activities between nodes, and also opportunities for things to go wrong if there are bad actors who want to alter the state of transactions or be malicious in some way. The enemy city can be thought of as any man in the middle who seeks to alter the blockchain or do something else as a bad actor. Blockchain networks are built with predefined rules about what can happen, when it can happen, and how it happens. This makes transactions more predictable and dependable and creates a network of participants that must work together at all times. Blockchain systems are successful because trust is built into the system. This video is all about the history of Ethereum. Ethereum's creator, Vitalik Buterin, originally wanted to extend the Bitcoin platform, but the core developers weren't interested in deviating from Satoshi Nakamoto's vision too much. So he had to create something new. Buterin created a more general blockchain that has emerged out of the successes of Bitcoin. Launched in 2015, Ethereum is the world's programmable blockchain. It increases what's possible with the platform. What makes it different from Bitcoin is that you can use it for lots of different digital assets, even Bitcoin itself. It is still digital money, but isn't tied to a specific currency. In fact, there are a multitude of uses outside of just currency exchange. Ethereum is for more than just payments. It's for games, applications, loyalty programs, learning programs, and more. Ethereum is an open-sourced, global platform for decentralized applications. It is also smart contract-based. That means you can write code that controls digital value and runs exactly as programmed. Smart contracts code describes the rules for how your personal Ethereum blockchain should operate and who can participate. Let's explore the main benefits of Ethereum. You'll notice that many of these are the same benefits that Bitcoin provides. The Ethereum blockchain network provides accessible banking for everyone, privacy by not needing to provide your personal details and instead using your set of public and private keys. Ethereum is a peer-to-peer decentralized network that is censorship resistant. And what's more, Ethereum provides the ability to work with commerce and provides nice compatibility with other platforms and products. You can think of Ethereum as a Bitcoin computer. Ethereum has its own currency called Ether, but it also allows you to create your own cryptocurrency. If you want to buy some Ether, you can use a cryptocurrency exchange like Coinbase or Kraken. To get started, you can get some Ether yourself that you can use on different platforms and send some to others. To learn more about how to buy, I recommend going to ethereum.org/ETH. There you can find recommendations about how to buy Ether. You'll also need a wallet to manage your Ether and your Ethereum account, which will allow you to store, spend, and receive Ether. You can find out about how to sign up for a wallet at ethereum.org/wallets. Plus, there are many products and services built on Ethereum blockchain network. Those are referred to as dApps, which stands for Decentralized Applications. These are web and mobile applications that are powered by Ethereum smart contracts. To find out more about some of these applications, check out ethereum.org/dApps. Ethereum's blockchain network works much like Bitcoin's blockchain network. The blockchain is composed of millions of transactions. These transactions are grouped together into blocks. Each block has several transactions, and each block is chained together. For a transaction to be verified, it must go through the mining process where miners solve the current block puzzle and create a new block of valid transactions. A miner is able to solve the current block problem using the proof of work algorithm. When a miner validates a new block, they're rewarded with a certain amount of Ether. Currently, that amount is about 2 Ether, but this amount can continue to change and reduce over time. Transactions take about 10 to 15 seconds to be verified, as opposed to 10 minutes with Bitcoin. Where Bitcoin limits blocks to 1 megabyte of data, with Ethereum, you are limited to the amount of gas that you have. Gas is used to perform any operation on the network. You need gas for transactions. Just as a car can only go as far as the amount of gas you put into it, a contract will only execute up to the point of gas it has. This prevents people from running infinite or very computationally intensive tasks for which miners might not be compensated. The basic idea is that you need to pay for gas as you go. Ethereum is also Turing complete, which means that a program is sufficiently expressive and will have predictable behaviors. It also indicates that anything can be calculated, providing there is enough time and computing power. The part of the protocol that handles processing is called the Ethereum Virtual Machine, or the EVM for short. The EVM is a Turing-complete virtual machine. Ethereum also used an expressive language called Solidity. This allows programmable smart contracts versus simple currency transfers that are allowed with Bitcoin. The code needs to be compiled to an intermediate bytecode representation, which can be executed on the different platforms. Each node executes the code and verifies the result. When a developer writes smart contracts for Ethereum, they typically write code in Solidity that is compiled and run on the Ethereum virtual machine. So that's the overview of Ethereum. Ethereum was built off of the ideas of Bitcoin, and it is wildly popular since it is a programmable blockchain and has many other use cases outside of just cryptocurrency transfer. At the time of making this video, the Ethereum core development team is working on Ethereum 2.0. This will essentially rewrite the platform and make it more scalable to move from a proof of work to a proof of stake consensus. This is exciting as Ethereum continues to improve and evolve over time. Now that I have discussed a bit about blockchain and cryptocurrency, let me take a few minutes to discuss how blockchain is made secure with the use of cryptography. Blockchains get their properties from cryptography. In fact, Satoshi Nakamoto's paper references cryptography quite a bit. In this video, I'm going to discuss three concepts: hashing functions, public key cryptography, and digital signing. Hashing functions are crucial to the cryptographic primitives that make up the trust we need in cryptocurrencies. Hashing functions are algorithms that perform one-way transformation to convert input to fixed size output called a digest. Hashing functions have extremely large input spaces, but they generate much smaller output spaces. They generate a known outcome from arbitrary input, but not the other way around. And this is the key to the proof of work algorithm. For each round of mining, the goal is to find a solution in the output space that meets certain characteristics. The mining nodes need to try to find an input that maps back to the output. However, you can't guess the input space, but have to search to find the correct input based on the transaction and the user's public key. They allow us to detect tampering and verify identities by providing the mathematical guarantees we need. The main principles of hashing functions are that it must be computationally unfeasible to reverse a hash. You cannot guess an input from the hash output. It must be computationally unfeasible to generate a message for a given hash. And it is impossible to generate another message that has the same digest. And third, it must be computationally unfeasible to find two inputs that generate the same hash, because we use the output as a way of verifying identity. So each input is unique. Hashing functions are one-way transformations where you can't go from the output space back to the input space. Proof of work calculation takes advantage of this asymmetry. Let's say I have a text message I want to send to someone and encrypt it. Any change to the document will generate a different key. If I know what the message is, I can tell that it's been modified. So this slide demonstrates the general notion of using SHA-256, which is a type of cryptographic hashing, which is a type of hash that's commonly used with Bitcoin. The input message is in the file message.txt. If the message is changed, it will generate a different hash output. A single character difference, you see password, changes to password, will yield a completely different digest. So we use hashing to verify that no tampering has occurred. So again, it's easy to generate an output, but with output, it's hard to find the source message unless you know exactly what it is. Digital signatures are used heavily in blockchain. To prove you are a person that did something, you take your data and use your private key to encrypt it. Then someone else can use your public key to decrypt that data and verify that you performed this transaction. So take a message as the sender and use the hashing algorithm to encrypt a message using your private key. Then you take the encrypted message digest and send to a receiver. The receiver can take the sender's public key to decrypted message and get back to the unencrypted hash. Compare that hash to the plain text message, and if that matches, then digital signing was successful, and that means the message could not have been tampered with. So now let's take a look at another example. And in this particular example, let's say that we have two users who want to facilitate a Bitcoin transaction. So you have the user on your left, Bob, who wants to send 10 Bitcoin to Alice on your right. So what Bob will do is create a transaction that contains Alice's public key and signs the transaction with his private key. Now that the transaction is signed, it says that Bob authorizes this transfer. This transaction can then be verified by checking the transaction's digital signature with Bob's public key. So Alice can use Bob's public key to verify that this transaction was valid. If the hash of the unencrypted transaction matches the hash that was encrypted with Bob's private key, you know that this transaction is valid and therefore approved by Bob. So this is how a transaction is authorized generally. And this is kind of the method that you would take to actually verify this transaction. So hopefully that helps your understanding of the foundations of blockchain cryptography. The asymmetric encryption nature of public key cryptography makes it so that transactions can be verified and confirmed in a secure way. Mining is the process of using computer hardware to do mathematical calculations for the blockchain network in order to confirm transactions and create new blocks. Mining is the term used with blockchain as a metaphor for the process of coal miners who extract material from the earth. Blockchain miners extract blocks. They do this by collecting transactions into a block and then submit a proposal after solving a cryptographic puzzle. The current block includes the hash of the previous block, which creates a connection. And this is really how all blocks are chained. The hash of the most current block has some information about the very first block in the chain.
Sorry, I didn't.
Where is Ray's boathouse?
I'd be glad to help you find that place. I need your location to help. Ray's Boathouse is about 12 miles away at 6049 Seaview Avenue Northwest in Seattle.
Hi there. This is Alexa. How can I help? Uber can help with that. There is an Uber X 4 minutes away from your Uber home address. Should I order it? Have a nice day. What else? Hi there. This is Alexa. How can I help? Okay. How else can I help you?
Totally. I pulled up some videos for you. I wish I had a hanky to offer you.
Hi there. This is Alexa. How can I help? Okay. Is that all? I found a raised boathouse. It's 20.2 miles away on Seaview Avenue in Seattle. Business hours for this location are not available. What else?
Ray's Boathouse is about 14 miles away at 6049 Seaview Avenue Northwest in Seattle.
Hi there. This is Alexa. How can I help? Uber can help with that. There is an Uber X 3 minutes away from your Uber home address. Should I order it? Okay. Would you like to hear more options? Have a nice day. What else? Okay. How else can I help you? Okay. What's next? I like Cortana. We both have experience with light rings, although hers is more of a halo. Is there anything else? Sorry, I'm not sure. How else can I help you? I don't know that. How else can I help you?
What they're actually what they're actually trying to do is be the first miner to come up with a 64-digit hexadecimal number or hash that is less than or equal to the target hash. It's basically guesswork to try different values until they find the right hash that matches the goal. We know the output, so we have to find different hash input combinations and see what is generated to see if it matches the output. Miners are given a nonce, which is some random number, but they can have a starting point to guess the correct hash. Initially, 1 in 16 hashes would have worked, but every 2 weeks or so, the hashing throughput of the network grows sufficiently, and the target is reduced in size. Each shift from the target to the new target represents 16 times more work, because it is a hexadecimal base 16 number, and will therefore take longer and use much more computing power and have a higher hash rate. Proof of work is the algorithm used by Bitcoin, Ethereum, and many other blockchains. One big downside to proof of work is that mining consumes a lot of energy. In fact, the amount of energy currently being consumed on mining is equivalent to the amount of energy that some countries use. Successfully and securely on an ongoing, you might be wondering what all goes into a transaction and what information they contain. This video is all about breaking down what a typical transaction looks like in the context of a blockchain. For the purposes of this video, I'll examine a Bitcoin transaction on blockchain.com. We can do that by visiting blockchain.com/explorer, which allows you to explore helpful information about Bitcoin and Ethereum, including the latest blocks and transactions. Let's start by looking at the very first Bitcoin block, also known as the Genesis block. Like I've mentioned before, the beauty of the blockchain network is that you can look back all the way to the beginning of the blockchain and see the transactions in blocks. So here we see the very first block, block 0. And this block was created by Satoshi Nakamoto himself to introduce Bitcoin. In the message of this block, Nakamoto included the headline from New York Times that day, which was about the banks being on the brink of a second bailout. That is said to have been a statement about Bitcoin being introduced to solve the problem that exists with modern currency and centralized big banks. I'll walk through the pieces of this transaction one step at a time. So first up is the hash. The hash is the unique identifier for this particular block. This is a 256-bit hash that was generated based on all of the transactions in the block. Then there are confirmations. Confirmations are the successful act of hashing a transaction and adding it to the blockchain through mining. These indicate how many other times this block has been verified in this network. The timestamp then shows when this block was added after first being confirmed. The height is the number of blocks connected on the blockchain, which is currently 0. The next block in line would be block 1, and the latest block would be that block number. The miner name is the name of the miner who confirmed this transaction in this block. As you can see, this miner is unknown. If I click on this link, however, I can see the profile, which contains a public address that is derived from this user's unique public key. So there you can also see some other details about this user, like transactions that they have completed and how much they've sent and received into balance. For Bitcoin, typically the miner name is shown in that of the mining pool. The number of transactions in this block is just 1. As a reminder, with Bitcoin, each block can have up to 1 megabyte of data, or thousands of transactions. I also see that this particular transaction is 285 bytes. The difficulty of this first block was 1.0. So difficulty means how hard it is to find the current hash to the block. The difficulty started out at this baseline level, but has grown tremendously by many magnitudes over the years, and it's constantly adjusting to keep time to create the new blocks around 10 minutes. The Merkle root is described as the root node of a Merkle tree, which is the descendant of all the hashed pairs of the tree. So to put it another way, it represents the hash of all the hashes of all the transactions in the block. So since there is only one transaction here, the Merkle root that you see is also the same as the transaction hash, which we see down here. The block version refers to the number of related protocol proposals underway. The bits represent a subunit of Bitcoin, where 1 million bits is equal to 1 Bitcoin. And the weight is some measurement to compare the transactions in relation to the size of the block limit. The knots is the random value that can be adjusted until the correct hash is found using proof of work. The transaction volume shows how many Bitcoin were included in this block, and for this block, it is 0. The block reward is the reward for the miner who calculated the hash for the block, and
consoles. The same team that set the bar for live gaming services with Xbox Live, this same team set out on a new mission to create the future of gaming for you.
When we think about the future of gaming, it's not just PC, it's not just console, it's not just mobile. It's really all of the above.
Xbox is all about choice. We're investing in technology all throughout the game stack.
The games you want with the people you want on the devices that you want.
And for us, that starts with our next generation console.
We don't want to build just another console. We truly want it to be transformative.
More immersion, more exploration, more detail.
How do we make it easier for people to get into the game, to stay in the game?
One of the things that gamers and developers are incredibly excited about is reducing load times.
I'm an RPG gamer, and so loading screens are a thing.
You're sitting there in the fake elevator because you know that the game's loading in the background. That's just an elevator ride forever.
That's our goal with gaming, is that you don't have those pauses.
This generation is going to be a bigger leap than any generation we've done before.
At the heart of our next generation console is our custom design processor, leveraging the latest Zen 2 and Navi technology from our partners at AMD. From a pure processing perspective, this is 4 times more powerful than the Xbox One X. We're leveraging high bandwidth GDDR6 to ensure that we're getting the best performance possible.
It's going to usher in resolution and frame rates that we've never seen before. Never seen before.
We're looking at frame rates up to 120 frames per second.
8K capability.
Variable refresh rate.
Next gen ray tracing. It's real time because it's hardware accelerated for the first time ever.
What I'm personally most excited about is the SSD.
We've created a new generation of SSDs. We're actually using the SSD as virtual RAM.
We're seeing more than 40 times performance increases over the current generation.
The combination of the SoC and the solid-state drive are really what gives you a totally new experience.
Now we can take all of that power and apply it back into the scene, so we can actually generate more life in that world and bring it to the gamer in a seamless way.
So that then you're fully experiencing what the game developer wants you to experience.
When you can move through worlds without waiting for screens to load, that speed, that performance is what the next generation is about.
This is the most immersive console experience ever.
What we really want to do is give developers the power to build the game they've always envisioned.
We have hundreds of people across both our first-party studios as well as our third-party studios working on those next-generation experiences today.
There's an amazing commitment to content at Xbox Game Studios. There's 13 studios.
Okay, well, good morning, everyone, and good morning, those of you who are on the phone. Super to see everyone here on this Friday morning. In fact, it's super to be back in the family, having been on the road for a few weeks with the worldwide mid-year circus, tour. You know, it's just phenomenal to be back in the business. We started with a couple of wonderful customer meetings yesterday, and Nicole and Dan, thank you for bringing me back to reality with a discussion with the Fujitsu executives on Skylake and pricing and everything like that. So yeah, I was back to sprint speed with our customers and getting a real sense of what our partners are going through. But this is the agenda today. So we're going to go through business update, We're going to then get some customer insights from Venki. Michelle's going to give us a really, really interesting talk and talk about, our most valuable asset. Then we've got Mike Nichols, and then we'll finish with a little celebration on awards and tenure and things like that. So we'll keep it sort of fast and pacey. If we've got time, we'll do some Q&A, and then we'll set everyone free pretty quickly on the hour there. I want to start off by actually telling you a little story that my wife Brooke and I discussed this morning. It was like a fairly rare occasion that we're getting up and getting ready in the morning together. We had coffee at 5:30 this morning. And my wife's a doctor, so she's been on night shift while I've been away. And so my mom, who's been living with us for 3 months, which is seriously awesome, other than the continual review cycle, she looks after our 2 kids of 2 and 6, and we have a nanny that kind of helps out during the day. But Brooke's like, I have to tell you about this text I got at work yesterday. And so she got a text from the nanny. It was 11 o'clock in the morning. She's like, it's made my whole week. And she said, so when, you get a text from the nanny, it's usually panic. Why is the nanny texting you during the day? But Alyssa texted Brooke and said, I just have to tell you this. I just took Olivia, and that's our 19-month-old, and Blue, the dog, the golden, out for a walk. And anyway, we came back, and Blue, as usual, rolls in the puddles, gets covered in mud, goes in the living room, and then rolls on the carpet. And so she's like, Blue was rolling on the carpet, and Olivia, the 19-month-old, she's at that waddle, walk, crash stage. A bit like Windows 10. But so she's at that stage. That wasn't scripted. She's at that stage. And Alyssa said, cutest thing, Blue comes in, he's rolling on his back, he's got his paws in the air. And Olivia walks in, she sort of waddles across the carpet in the hall, and she looks at Blue, who's the dog lying there with his paws in the air, and she high-fives one of his paws and then walks off. It was like the cutest thing. Brooke's like, that just made my day. And we're just sort of teaching it a high five. And she saw the dog with his paws in the air, and she sort of walks up, she high fives him, and then sort of walks off into the kitchen. That's like my story of the week. And Brooke's like, no matter what I have to deal with in the E-room this week, it's this sort of the simplicity and the honesty of, sort of babies and puppies that, is that kind of human. So, in my spirit of high five, this is some of the stuff that we should all, metaphorically high-five each other in New York. So since we last met, and really sort of since the end of the year, this is just a few of the bigger things we've done. Not to mention, kind of our day job is just getting in there, getting Windows 10, getting it licensed. I mean, of course, Windows 10 is all-consuming for all of us, but just look at the stuff we did. We did the world tour, so we were on every single place. We launched all those devices, whether it was, we're talking to Kevin from Xbox today, I couldn't remember which country we had the team in when we did the sort of the Asus launch or the Republic of Gamers launch in the Meatpacking District in San Fran 2 days earlier. We'd been in Taiwan, and I know that this org just bust their guts to get all of that done. I mean, we went around the world launching all of those new devices. We then pulled off CES, which probably had some of the more serious, deep business discussions than we've had before. I mean, Marie reminded me of the levels of depth and discussion we had when we're doing some pretty dramatic things in the ecosystem right now with our economics and our programs and our pricing, not to mention moving to the sort of evergreen OS. We're almost in kind of 3rd generation of Windows 10 already, when we're just 6 months into the thing. And these are huge. We did the worldwide mid-year. Now, thank you to everybody who spent time and effort and brain cycles and nights and days to produce a view of our business from our field, take the field view in, things that we would do. It really makes a difference as we start to understand exactly what's going on right down in the very depths of countries and what they need from us in terms of just devices or prices or device and prices. Just the real feedback in terms of how they have to deal with, Forex or technical difficulties, or the fact that Cortana just isn't available in their language, which means 30% of all the case studies and marketing that they receive from Windows are irrelevant. There's stuff that we take for granted that I now, so many more of you, because of that sort of iterative process of getting into the worldwide mid-year, that we are now smarter and better able to build devices at the right prices that delight customers. And thank you so much for that effort. It was huge amount of effort. You know, our finance business partners, as well as the business management team, went around the horn a few times. And when I say that, I mean literally round the clock, a few times revving those slides. And the process of mid-year is actually a better learning process than the hours spent in the room, because it really does force us for that sort of deep inspection all the way through our business and back again, and then be accountable to what we're going to do about it. And on top of that, we then have this ability to sort of display it to the SLT and to Satya and to Kevin and everything like that, and just decide, do we need to make some adjustments? The other point is, it's the middle of the year. It's the single point of accountability to the numbers, where you say, I own this number, this is how I did in H1, this is what I'm going to do in H2. It's the single biggest moment where you stand there in front of your peers and your seniors and you say, I'm accountable for this and this is what I'm going to do. Which we are accountable, we have a number, we love, but it's good to also get that same back from the SLT and from the business groups. You know, OST, a little word with a lot of work. You know, this is massive. The changes going into OST, the team working it. And don't forget, OST has, you know, this thing's a hydra, it's an octopus, it's famous. I had the first time in a meeting where an OEM had printed it out and handed it to Terry in a meeting. This was this week. There's a few of you in here that were in the room at the time. So one of the OEM CEO direct reports printed out OST. And had obviously had quite a lot of highlight sort of phrases and sentences on it, and handed it to Terry and said, Terry, have you seen this? And Terry looks at it and is like, no, what's this? And he said, well, that is the guidelines for how the things that you do and the things that we do come together. Are you aware of paragraph 3, section 2, line 4? And Terry's like, wow. And, you know, kind of he looks at me like, sort of help. And I'm like, yes, it's shorter than it's ever been. You know, what are you going to say? And you know, of course, we're very excited to partner, and it's just been a great relationship, and, you know, the standard lines. But, you know, OST is huge, and there's such fundamental changes we're making in that document that represents how we've changed, how we build software, and how PCs will get better and better and better over time for people that are using them, compared to, you know, single things that happen with multi-year sort of value cycles. And the OST is really, it's the pinnacle of how we're trying to build the ecosystem to act in a seamless, predictable way, so that all of our customers, the very end users, whether you're a business or you're launching a spacecraft or whether you're playing a casual game or whatever, how that Microsoft can continue to add value through the life cycle of that device and do that in concert with OEMs. When we move an ecosystem, we move millions of people, we move millions of, you know, trillions of dollars of business from all the way through the supply chain. Having a document like that I really truly believe for what it's doing is actually a pretty small document at a very, very important point of pivot in the industry. How people build, you know, PC equivalent devices or personal devices shows our leadership and shows, really, in this room, that document determines the future of the device ecosystem. And that's why it is so important, and why so many people are working on it, and so much sweat and tears and feedback goes into that. And so that's huge. And we're getting closer and closer and closer. This thing's becoming sort of a finely carved document that will land how we do the ecosystem, how we build devices in an evergreen world, how we build devices in an active branch or a long-term service branch world. You know, I love the bite and the might, and I don't know if I ever say it right, bitey or mighty, I'm not sure. Chris regularly corrects me. I still get it wrong. But, you know, this event's getting bigger and bigger. I love to see more and more sellers at the event. As I say before, any seller that wasn't at the event, the other sellers figured something out that you didn't. You know, that is just such a great way to just kind of continue to invest in each other, continue to build capability. Quite frankly, just resume value. If you know everything, or you really think about everything that you could have learned at those events and the things you did, you're adding value to yourself, whether it's inside Microsoft, whether it's in your next role in Microsoft, but just to you in your careers And those events are just great. No one else really does it at this level. I'd love to make it this sort of online local language university, and we can start thinking about some of those things in the future. But it's a great way to understand how the digital physics and the solid physics of IT come together when you get hands on a device that enables you to really access the cloud in a way that feels natural and relevant to you, is all through the device, and that's what those events do. Bet, I don't know if it's Felicia here, but the Edu team, our team, the device team did a very, very good job at supporting both our partners at Bet, but also supporting Microsoft at Bet. This is one of the big, it's sort of like the CES of education for IT. And in a former life, I used to have to work the stands every day at Bet, but for a hardware company. But it's in the UK. It's the global education, technology event. And as we push more and more into our education stack, now don't forget, we all think that Chrome wins every single day. We still have the largest amount of share in education of anyone by a very long. Now we're very sensitized to the fact that when you go from all of the share to losing 5% here or 10%, or in fact, 20, 30, and so on in some of the US examples, we think of the, Edu as this Chrome phenomenon. It's actually not. It's a Windows phenomenon, and Word, Excel, PowerPoint are still the top 3 tools of Edu worldwide by mass. But our push through of the stack from device to cloud is so critical for the future of people that use the devices. As we all know, you're most familiar with the thing you were doing yesterday. And going from schools on, the Windows stack or the Microsoft stack, going into further education, going into higher education, going to the workplace, or just from school to the workplace, you tend to use what you're familiar with, and the workplace tends to use things that people are trained for. It is so critical for our future that learning minds learn better on Microsoft. And not only that, but actually our approach to that, which is not to find out what everyone's doing and sell them shit online to make money, is also a much better approach for the planet. And so these events have become more and more critical, but also building that device-to-cloud experience in a seamless, easy-to-use way is the key. And we'll talk a little bit about that when we start talking about some of the investments we're making in bundling things like Lightspeed and classroom orchestration and some of the other assets that was a big topic at mid-year. So that's Bet. IoT cross-company strategy, and I'll talk about a few of the heroes that just I kind of have the sort of the hero of the day. If I look at, we gave Rodney and Kiki and the team, and forgive me because I know there's a lot of other people in it, so just take those two as just 2 examples that I've been engaged with. A fairly easy mission, which was, just go off inside the company, consolidate a view of what IoT is, what our strategy should be, and then come back and stand in front of the CEO and recommend the things that Scott Guthrie and Terry actually should be doing. As it relates to, the world's biggest opportunity, 3.5 billion devices, or, 1.5 billion intelligent systems and 9 billion, microcontroller sort of market business. And then just make sure that everyone's aligned before we move into that room. I mean, this is just phenomenal. Let's kind of keep this in the family because I'm sort of washing laundry, partly for comedy and partly because it is just hard doing this. The first few meetings, and when you sort of get to a partner, you'll realize that you generally avoid your manager. You come back with like, hey, look what I've finished, right? And so Rodney and I, he was, so I was like, oh, Rodney, how's it going? It's like, yeah, it's good. We got a framework. We're inviting people to meetings. It was pretty clear that our company doesn't have a line strategy. So just think of this at this level. You kind of got Kevin Dallas that owns IoT from All App Strategy for the company. And you've got Terry that owns client strategy. And you've got Scott Guthrie that owns cloud, and Jason Zander that owns Azure. And these people are building, $40, $50 billion businesses and writing the technical architecture. And so Rodney's inviting them to the meeting to talk about how do we make all of our stuff work together, because there's this huge opportunity, and you've got the cloud saying, it doesn't matter what it runs, it'll talk to us. And you've got the clients people saying, if it runs this, it will be better. And So I went to one of these meetings, and it is like, both sides of the table. Well, our stuff, well, we're all cloud, and well, we're all client. And when you start to think of who makes the money, today, Rodney's business is $800 to $1 billion, if you had the services attached. OEM is the one making actually the money right now from IoT. We've got 40, 50, 60 million of Azure meters spinning on devices that are generating data that can go to the cloud, that can then be, interrogated and, give you good information on what your sensors or what your device or what your hub's doing. But at the end of the day, it's actually the people who are making the money that have to kind of bring this together. And it was just such on one level, it was comedy because there were people who would just refuse to attend the meetings. Yeah, no, I'm not going to a meeting where you're going to talk about using, a Linux client or an Android client. Well, I'm not going to a meeting where you're saying that my whole cloud has to be, optimized for a single Windows client that's less than 10% of the business. So that's just at a human level. Now, he has a goal to go and stand and present an aligned business in front of the CEO of how we're going to go after IoT. Kiki, of course, has the goal of putting the deck together that shows, a single opinion across the whole company. This is just such a phenomenal mission to have. It's largely impossible, of course. But you have a very fine point in time. At 2 p.m. on whatever the date was 3 days ago, you will sit in front of the CEO and you will say what our end-to-end IoT strategy should be. And the CEO's directs, who all sit either side of Satya in the room, will then say, why are we having a product technology room in this room? And we've never seen this deck before. Now, anyway, I'll net out the sort of point. But the process of having to pull together the whole of the world's